Now on my last problem on this page, I have a funny looking polynomial, and when you see something that looks like that with lots of variables and lots of big numbers in front, think about what should be your first step when you're factoring. And that's always to look for a greatest common factor and pull it out. So let's do that first, and I'm hoping that'll make my problem look a lot more reasonable. So if I look at this, I have 12, negative 22, and a positive 8. I can pull out a 4 from both of these, but not from the 22, so I better stick with the 2. And then I look at the variables. I have an x cubed, x squared, and an x. The smallest exponent is to the first, so I just can pull out an x. And then I have a y on every single term, so I can pull that out as well. And 2xy times what will give me 12x cubed y. 2 times what is 12, so that'll be a 6. X times what is x cubed, so that'll be x squared. And then y times what is y, it's just a 1, so I'll just leave it as 6x squared. Then my next term, I know I need a negative. 2 times what is 22? The answer is 11. X times what is x squared? There's just an x there. And y times 1 is y. Then for my last term, 2 times what is a positive 8, and that would be a positive 4. And x times 1 is x, and y times 1 is y, so I don't need to write anything else but the positive 4. Now if I wanted to, I could distribute the 2xy inside the parentheses to double check that what I come up with is what I started with. And at this point, I'm looking at the part inside the parentheses, and I want to use the sum product chart on it. And I want you to notice that this time I don't have a 1 for my lead coefficient, so I cannot use my shortcut. But I will use the sum product chart. My sum is going to be my middle term, the coefficient on the middle term, which is a negative 11. My product is going to be the product of the two outsides, which will be 6 times 4, which is 24. And I do need to make sure I keep these signs. If I had a negative here, this might need to be a negative 24, but because they're both positive, that'll be a positive 24. Now I'm looking for factors of 24 that add up to 11, and specifically a negative 11. So I know that 1 times 24 is 24. I know 2 times 12 is 24. 3 will also work 3 times 8, and I think I'm fairly close here. So I have two things that multiply to give me a positive 24 and add up to a positive 11. Now I needed them to add up to a negative 11, so I have to think a little bit more. I know it should probably be that 3 times 8, and if I make them both negative, when I multiply negative times negative, I'll still get a positive, and when I add them, I will get that negative 11. So my pair is negative 3 times negative 8. And I'm going to use them in place of the negative 11x. So remember that 2xy is my greatest common factor. It'll just come down to my answer. And then I have the 6x squared minus 3x minus 8x plus 4. Now I need to think about factor by grouping, my first pair of terms and my last pair. For the first pair, I can see I can pull out a 3x, and what I have left then is a 2x minus 1. If I distribute, just to check, because there are a couple of unusual things here, 3x times 2x, that is 6x squared. Okay, then 3x times negative 1, that'll give me the negative 3x. So that's correct for the first pair of terms. Now for the last pair of terms, I see I can pull out a 4, and I have to think, do I want to pull out a positive 4 or a negative 4? And because my first term starts with a negative, I think I'll try a negative 4. And if I pull out a negative 4, then negative 4 times what is going to give me negative 8. So that'll be a positive 2, and I need to keep that x there. When I multiply these two, negative 4 times 2x, that's negative 8x, which is my first term. Now I need something for the second term. I have negative 4 times something should give me a positive 4. The only way I can get that is by multiplying by a negative 1. So negative 4 times negative 1 is positive 4. Now remember, I still have my greatest common factor out front, and now I'm to the point where I'm looking for another greatest common factor inside the big square brackets, and I see it's this quantity 2x minus 1, so I'll pull it out to the front. 2x minus 1 out to the front, and what's left is this 3x and this minus 4. And of course, bring down the 2xy. And there's my solution. Now to check, remember, I would do like I did on that previous problem where I had a greatest common factor. I'll use FOIL first on these two binomials and then distribute the 2xy. Okay, you might see some problems like this where we have a perfect square trinomial, and if you don't recognize it as such, that's not a problem. But if you notice that the 25 is a perfect square and the 4 is a perfect square, it might help you out a little bit when you're trying to solve this problem. Remember, the first thing is to look for a greatest common factor, and I see a 5 times 5 goes into 25, and a 5 will go into 20, but 5 won't go into 4. So I don't have a greatest common factor for the number parts. And this one has an x, and a y, and a y. So there's nothing in common on all three terms as far as the variables go. So I'll just look at a sum product chart. My sum should be 20, and my product should be 25 times 4, or 100. Now when I'm working with a perfect square trinomial, where this is a perfect square and this is a perfect square, I should look first for the square root of the 100. And I know the square root of 100 is 10, so 10 times 10 is 100. And if it is a perfect square trinomial, these two will actually add up to the sum that I have for the problem. And since 10 plus 10 is 20, I do have my pair, and it is a perfect square trinomial. So I'll plug in the 10 and the 10, because remember, I cannot take the shortcut on this problem. I do not have a 1 for my lead coefficient. So I have to say 25x squared plus 10, and I'll use the same set of variables, xy plus 10 xy, I needed 2 tens, and then plus 4y squared. Now I can look at the first pair and the second pair. The first pair of terms has a greatest common factor of 5x, it looks like. And 5x times 5x will give me that first term. And then 5x times 2y will give me the second term. And when I look at this last pair of terms, I can pull out a positive 2y. And what I have left is 5x plus 2y. Now one more time, looking for a greatest common factor, I see that 5x plus 2y is the same on both, and I can pull that out to the front. And what's left is exactly the same thing, and that's what makes it a perfect square trinomial, because it's also equal to 5x plus 2y quantity squared. I can write it this way, or I can write it this way. They're both equivalent. Now I want you to look back here at my sum product chart. I wasn't able to take the shortcut, and I want to show you again that no, indeed, the shortcut won't work on this problem. I came up with 10 and 10, which would mean that if I was taking the shortcut, it would have to be x plus 10, x plus 10y for both of them, and that is absolutely not what I came up with. So the shortcut definitely did not work when I did not have a 1 for the x squared term. So no shortcuts on this problem. Work it out the longer way, and there's your results.